Okay, so today I want to show the demo of my project, which is the FPGA-based audio DSP coprocessor for Tiny RISC-V CPU. The goal of this project is to implement an audio DSP coprocessor for audio applications integrated with a 5-stage pipeline RISC-V processor on the DE1-SoC FPGA platform. And the audio DSP coprocessor can do the LIR filtering and pinch shift. Okay, now let's do the demo. And you can see at the left hand side, here's the assembly code for the vector addition. So the system can do the vector addition on the general purpose processor, and it can also call the audio DSP coprocessor to do the IR filtering and pinch shift. The right hand side shows the assembly code for the sorting algorithm, and we can do the sort for the 10 values. And we can also call the audio DSP coprocessor to start IR filtering and pinch shift. And besides, based on this assembly code, I also got the disassembled version to be downloaded by the FPGA side. So here you can see here's the disassembled instruction and disassembled data, source value, sync value. So based on these, and these values will be imported into the HPS side, so the software side of the FPGA, and it will enable to do the connection to communicate with the hardware side about the FPGA to do the job. Now let's do the demo of the whole system. So I've prepared two interesting demo. The first one is the sorting. So which means let's compare sort first, and let's do the things like this. So which means after I click in, I don't need to compare the FPGA, it is already done. So after I input these instructions to the FPGA side, and it will doing the sorting algorithm, and it will output the value, and it will also start the audio DSP coprocessor. And I got pinch shift 1, so it will gonna have a very interesting sound compared to the original voice. And okay, and now let's do this. So, and you can see here here's the value of the finished data RAM, and you can see all the values are quite well sorted. And okay, now let's look at the FPGA side. So we can turn on the voice, and you can see here's kind of a very interesting sound we got. And this is kind of pinch shifted, so we can also show the original sound.
Here's how things used to be. Here's how they are today. Here's where they're going in the future.
So
a chronological structure.
Cool. Now let's do another one, which is about the vector addition. So basically for the vector addition, let's do comparing first and vector addition. Yeah, so basically we will have two array of vectors, and we can add them together on the general purpose processor side, and we can also start doing the IR filtering and pinch shift at the audio DSP coprocessor side. Okay, so sorry. Okay, so do it again, and we can hear the sound starts. So this original sound, and voice, and we can think because here I use a pinch shift 3, so it will have another type of voice which is quite interesting and robotic speaking. And we can also look at the context here. If you listen clearly, it's quite interesting. Okay, now let's look at the instruction side, and we can see here we got some like expected value here, and here's expected value, and here's the finished data RAM. So you can see here they're exactly the same, so which means my output meets my expectation. So yeah, it's quite cool to see like it works well.